Okay, so today we're looking at how to do our stoichiometry calculations. Now, stoichiometry is basically just a big long word that says using ratios to make calculations about chemical equations. All right, so what we're going to be using is a series of ratios, a series of equalities to help us make some calculations about mass, about moles, about all those things that we've been talking about since the beginning of the year. So we're going to be using two things to help us out in this video. First off, we're all going to be basing all of our questions off of one equation. Magnesium, 1 mole of magnesium plus 2 moles of sodium fluoride gives you 1 mole of magnesium fluoride and 2 moles of sodium. All right, so it's a nice little single replacement reaction, already balanced for us and such. So we're going to be basing all of our questions on this equation. We're also going to be using a mole map. And what this mole map shows us, on the left side, it shows us what we've been given. All right, so we can be given grams or atoms or a volume eventually when we start talking about gases, or we can be given moles of some substance. A is going to be the substance that we're given. On the other side, we have B, what we want to find, different substance, B, grams of B, atoms, volume, or moles of B. What these all show is how many steps it's going to take to get from place to place. So if we have grams of one substance and we want moles of that substance, it's a one-step conversion. And it shows us that we need to use molar mass. If we want to go from moles of a substance to moles of a different substance, we need to use a mole ratio from a balanced equation. However, it's also a one-step. However, if we wanted to go from, say, atoms of one substance to grams of another, we would need to start with atoms, use Avogadro's number in one step to convert to moles of that same substance, use the mole ratio to convert from moles of A to moles of the second substance, and then in a third step we would need to go from moles of B to grams of B, second substance, using the molar mass. We'll show you how to do all of those conversions here. All right, so let's get ourselves started, and we're going to look at our first question here. Given 3 moles of sodium fluoride, how many moles of magnesium fluoride can be made? Okay, so we've got our equation down here. All right, let's just keep that in mind. Ooh, let's scoot that down a little bit for you. 3 moles of sodium fluoride, how many moles of magnesium fluoride can be made? All right, so drop this on top here. Now, we're starting off with moles. So if we look at our mole map, we've got moles of something here. The question asks, how many moles of magnesium fluoride? Well, we start with moles and it asks for moles, but they're of different things. Okay? Well, that tells us it's going to be a one-step conversion. Let's see how that's going to work. Given 3 moles of sodium fluoride, we're always going to write out the entire given, all right? Unit, or number, unit, and substance. And then before we do anything else, we know we're going to need to cancel out the given. So bring down the unit and the substance. The mole map shows us that we only need to go one step. And what else also cool about the mole map is it's going to show us what needs to go on top. We start off with moles of A, moles of the first thing, and it started out on top. We need moles of B, moles of the second thing, on the top of the first step. So this wants moles of magnesium fluoride. Now, the mole map did say to use the mole ratio from the balanced equation. All that means is we need to look at the coefficients of our balanced equation. Moles of sodium fluoride, we have 2 of them. Moles of magnesium fluoride, we have 1 of them. We have our numbers, we have our units, we have our substances. All we need to do is do the math. 3 times 1 divided by 2 gives us 1.5. Now, I will admit that I made a mistake here. This should be 3.0, and this would be 3.0, just to give ourselves enough sig figs here. Now, 1.5 what? Because 1.5 is not an answer. We have moles of sodium fluoride that have gotten canceled out. We are left with 1.5 moles of magnesium fluoride. So that's a simple one-step conversion. Let's see a couple more. Our second question, if 4.00 moles of magnesium are used, how many moles of sodium fluoride are needed? Okay, so we're given 4.00 moles of magnesium, and we're asked for moles of something else, moles to moles. Again, a one-step conversion. So let's set up our given. 4.00 moles of magnesium. And we know before we do anything else, we need to cancel our given. The mole map again. We start off with moles of one thing, we want moles of the other thing. It says to use the mole ratio in that one step. And we know that moles of the second thing have to end up on the top. So it asks for moles of sodium fluoride. All we need to do now is look at the balanced equation to find our ratio. We have 1 mole of magnesium, we have 2 moles of sodium fluoride. So we multiply, divide, and cancel. 4.00 times 2 is 8.00. To figure out our units, cancel moles of magnesium, since it's on both the top and the bottom. 8.00 moles of sodium fluoride would be our answer. Okay. Let's see one that's got a little bit different focus. What is the mass of 3.50 moles of sodium? What is the mass of 3.50 moles of sodium? Well, we've got moles of something, and it wants mass. Well, it doesn't say what of anything else, so we have to assume it's the same thing. Moles to grams. Well, that's still only a one-step conversion. And it says we need to use the molar mass. These are conversions that we've been doing for a long time now. Use our given. 3.50 moles of sodium. And again, without even thinking, pull down the unit and the substance. We need the molar, rather, the thing is having us go from moles of one thing to grams of the same. We know that grams needs to end up on the top. Now all we've got to do is use the molar mass, which fortunately we've already gotten written down for all of these. Molar mass for sodium. Here it is, 22.99. And that is the mass of 1 mole. Well, to find our mass, all we've got to do is calculate. And we plug in our, get that out of there. We've got our calculator here. All right, put that off the screen. There you go. And so it turns out that we've got a mass of 80.465. That's it, grams, but we need to make sure that we have the appropriate number of sig figs. We only got 3 sig figs, so we cut this thing off. 1, 2, 3. Round. 80.5 grams of sodium would be our answer. Okay. So I know that just cut off into a separate video here, so we're going to try and hopefully be able to put that back together. Let's see another question here. Given 35.0 grams of magnesium, how many moles of sodium can be made? Now here's an interesting question, because we're given grams of magnesium, and it asks for moles of sodium, something different, okay, a different compound. So we've actually got a 1-2 step conversion. So let's see how this one's going to work. The first part always remains the same. 35.0 grams of magnesium. And we know that right off the bat, we're going to have to cancel our unit and our substance. Well, if we look at the mole map, though, we've got down to moles of A. It's got to be where we go first. We can't go straight from grams of one thing to moles of another. We've got to go from grams to moles in a single step, keeping the unit, or keeping the substance the same. So in the first step on the mole map, it says that we should end up with moles of A up on the top, which is what we've done. Next step, we can go to moles of B. So let's finish this one, write in what we know. 1 mole is 24.31 grams. And if you don't have this handy piece of paper, you know you can find that on the periodic table. Well, one thing that we need to check. 1 mole of magnesium, or rather moles of magnesium, is not what we want. This thing asks for moles of sodium. So let's go ahead and we need to add another step. That's our cue. Cancel automatically. Next, the mole map says to go to moles of A or moles of B, we just need to put that thing up there. And it says to use the mole ratio. So we want moles of sodium. To find the mole ratio, we just look at the balanced equation. 2 moles of sodium, 1 mole of magnesium. And now we just need to calculate it. So let's plug all this in. And we've got 35.0 times 2 divided by 24.31 divided by 1 gives us 2.87947 ... We only get 3 sig figs because of our given. We only get 3 sig figs, so 1, 2, 3. Cut that off. 2.88, and the unit. Moles of magnesium cancels, grams of magnesium cancels. We get moles of sodium. 2.88 moles of sodium. Okay. Now would be a great time to introduce 2 important rules that we always need to keep in mind. Those 2 important rules. Number 1. First, only change the unit or the substance in one step. So if we look at our last question, we changed from grams to moles, but we kept the unit the same. We changed our unit. Excuse me, we kept the substance the same. We changed our unit. Here, we went from moles to moles, but changed magnesium to sodium. Our unit stayed the same, but our substance did not. Here, the unit changed. Here, the substance changed. Only one at a time. The second big rule is to change substance, the unit must be moles. The unit must be moles. Okay, so cannot change the substance if your unit is not moles. Okay, so you need to make sure we keep those 2 major important rules in mind. We'll keep that one handy so we can go back and look at it again. All right, so we've got a couple more questions we want to walk ourselves through. With 4.00 moles of sodium produced, how many grams of magnesium did we use? Well, we again start off with our given. 4.0 moles of sodium. And without even thinking, bring down moles of sodium. Okay, now, here it says to go from moles of one thing to grams of another. We need to go through moles of the other. So that's our first step. We want to go to moles of magnesium. And it says to use the balanced equation, mole ratio. Moles of sodium, we get 2. Moles of magnesium, we got 1. Now, this one, moles of magnesium, is not what we want. We want grams of magnesium. So we need to do another step. Let's take a moment and make sure that we're following our rules here. We're changing the unit, or changing the substance. Okay, the unit's staying the same, that's all right. Second rule, to change the substance, the unit must be moles. Unit looks like moles, so we're okay. Moles of Mg, and we want to go to grams of magnesium, since the mole map shows us that what must be on top is when we want it. It needs to go from using molar mass. 1 mole is 24.31 grams. Check and make sure that everything cancels. Moles of magnesium cancels, moles of sodium cancels. We are left with, calculate that here. We've got 4 times 24.31 divided by 2, giving us 48.62 grams of magnesium. But since we only have 2 sig figs, that has to get cut off. 49 grams of magnesium would be our answer. One more 2-step problem, and we'll see how this one works. If 6.00 moles of magnesium fluoride are made, so start off with our given. Moles of magnesium fluoride. What mass of sodium do we have? Well, you got moles of magnesium fluoride. Getting rid of it. Ah! Now if you take a look here, it asks for, we're going from moles to grams. So again, we need to go from moles up to grams. Alright, it's going to be a 2-step conversion. We want to go to moles of the first thing, or moles of the second thing rather, and use your balanced equation. 2 sodiums and 1 magnesium fluoride. Bring down moles of sodium, we want grams of sodium. 1 mole, 22.99. Check and see if everything balances. Moles of sodium cancels, moles of magnesium fluoride cancel. Let's see, we have 6 times 2 times 22.99. Let's find out what that comes out to. Should be 275.88, which due to our 3 sig figs becomes 276 grams of sodium. One last question to work for, and this is a long one. You start with 45 grams of magnesium. How many grams of magnesium fluoride can you make? Well, your mole map says that, hey, we got grams and we got grams. That's a 1, 2, 3-step problem. All right, so first one, we're going to go to moles. Second one, we're going to use our mole conversion to go to our mole ratio to go to the moles of the other thing, and then find the mass. So let's lay it all out here. 45.0 grams of magnesium, and pull down grams of magnesium right away. The mole map says that to go from grams to grams of the other thing, we need to go through moles first. So convert to moles of, how do we know? If we're changing the unit, we know the substance has to stay the same. And we know that when we're going from between grams and moles, we need to use the molar mass. Molar mass, 24.31. Moles of magnesium is not what we want. We want grams of magnesium fluoride. So, moles of magnesium automatically comes down. The mole map says we're here. We need to get to here. Next step needs to go moles of whatever the compound is that we want, which is magnesium fluoride. Notice we've changed the substance, but our units stay moles, all right? So that is good. Moles of magnesium fluoride, 1 and 1. Now, the mole map says we are here, and we need to be up at grams. Use the molar mass. So we cancel out moles of magnesium fluoride, and we want grams. You change the unit. The substance needs to remain the same. 1 mole of magnesium fluoride is a mass of, calculated here, 62.31 grams. And now all we've got to do is calculate. Moles of magnesium fluoride cancel. Moles of magnesium, grams of magnesium. All we've got left is the numbers. Let's plug those in and see what we end up with. 45 times 1 times 1 times 62.31 divided by 24.31, and we should end up with 115, that's after rounding, grams of magnesium fluoride. So, things that you are going to need to remember. Your mole map. This is going to show you how to do every single problem on this unit. Using your mole map, you may only change the unit of the substance in a single step. Only the unit or the substance. And if you're going to change the substance, the unit must be moles. Remembering those 2 steps, remembering to use your mole map until you've memorized, is going to help you do all of these kinds of conversions much, much easier. And with that,